Hello and welcome to AI for Developers. I'm AI Educator Talking Bot. Today's lesson is titled Why I Rewrote My Trading Engine in Rust. Latency, safety and concurrency. Python, while excellent for prototyping and data science, becomes a bottleneck when applied to high-frequency or latency-sensitive trading systems. The global interpreter lock, GIL, limits true parallelism, and garbage collection introduces unpredictable pauses detrimental to order execution. To achieve sub-millisecond performance and deterministic behavior, a systems-level language becomes necessary. Rust provides memory safety without garbage collection, preventing common trading engine crashes due to null pointer dereferences or data races. Its zero-cost abstractions allow for performance comparable to C++ while enforcing stricter compile time checks. Rust's ownership and borrowing system facilitates safe and efficient concurrent programming, crucial for handling multiple market feeds and order executions simultaneously. Industry adoption in latency-critical systems is growing, acknowledging these benefits despite the steeper learning curve. Consider a backtesting scenario. A Python implementation, even with optimized libraries like NumPy and Pandas, suffers from GIL contention when parallelizing simulations. Rust can leverage all available cores without the GIL limitation, drastically reducing backtesting time and enabling more comprehensive strategy evaluation. Furthermore, serialization and deserialization of market data are significantly faster in Rust, impacting real-time data processing. The engine comprises several key components: a market data ingestion module, handling real-time feeds like Binance API or Coinbase Pro, an order management system, OMS, for order routing and execution, a risk management module to enforce trading limits, and a strategy execution module implementing your algorithmic strategies. Rust's actor model libraries like Tokyo or Async STD are excellent choices for building concurrent and resilient systems. Minimize memory allocations to avoid GC pauses. Even in Rust, excessive allocation can impact performance. Use lock-free data structures where applicable for concurrent access to shared state. Leverage kernel bypass networking for direct access to network cards. Reducing network latency. Employ CPU pinning to dedicate specific cores to critical tasks, preventing context switching overhead. Regularly profile your code using tools like perf or cargo flamgraph to identify bottlenecks. While Rust excels at low-level tasks, integrating AI requires bridging the gap with Python's ML ecosystem. Use a message queue, e.g., Kafka or RabbitMQ, to pass market data and strategy recommendations between Rust and Python processes. For customized agentic loops, design Rust modules that handle real-time execution based on AI-driven signals from Python. Private RAG, retrieval augmented generation, can be integrated by building a Rust service that indexes and serves relevant market data and research reports to AI agents, improving their decision-making. Deploy your Rust trading engine on bare metal servers or optimized cloud instances with low latency. Network connectivity. Implement robust monitoring with metrics like order execution time, market data latency, and system resource utilization. Use time series databases like Prometheus to track performance and identify anomalies. Ensure proper error handling and logging to diagnose issues quickly. Consider using infrastructure as code tools like Terraform to automate deployment and scaling, as trading firms increasingly demand performance and security. Rust's adoption will continue to grow, Expect to see more sophisticated Rust-based libraries and frameworks specifically designed for quant finance. Model v6 and similar advanced AI models will require the speed and efficiency of Rust to execute complex strategies in real time. Focus on building reusable components and well-defined APIs to facilitate collaboration and accelerate development. Remember, a performant engine is useless without rigorous backtesting and robust risk management. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.